Lesson 4.2 Area. The area of an object is the measurement that describes the size of the surface of that object. If you think of perimeter as the amount of baseboard you would need to put around the edge of a room, the area would be how much carpet you would need to cover the floor. To find the area of a rectangle, we have an equation. That equation is area equals the length times the width. So for example, if we wanted to find the area of the following rectangle that has a length of 6 and a width of 3, we use our area equation for area of a rectangle. So the area is 6 feet times 3 feet for a total of 18 feet squared. So I want you to notice that the units for area become squared. So when we were looking at the length, it was 6 feet and 3 feet, but the area is 18 feet squared. This is because we're multiplying a length by itself. So we're multiplying feet by feet. In the above example, we're multiplying 6 feet by 3 feet. So a foot times a foot is a foot squared. So whenever we're dealing with area, we take the units from our length and width, and they turn into a squared unit. So the next shape we're going to look at is area of a triangle. So if you think of a triangle as half of a rectangle, so if you look at the gray part of the rectangle off to the side, you can see that it's a triangle that is perfectly half of a rectangle. So if you think of a triangle as half of a rectangle, then the area of a triangle is half the area of a rectangle. So since the area of a rectangle is length times width, it would be half the length times the width for a triangle. But in the case of a triangle, we call the length the base, or the base of the triangle, and the width the height of the triangle. Therefore, the equation for area of a triangle is the area equals the base times the height divided by 2. So the base would be the distance along the bottom of the triangle, and the height would be the straight up and down height of the triangle. And then over 2 just means divided by 2 or cut in half. Let's look at an example. We're going to find the area of the following triangle. So I want you to use the area equation for a triangle that I just gave you and see if you can find the area of this triangle that has a base of 3 and a height of 4. Take a second, pause the video, and see what you come up with. Okay, so area of a triangle is base times height divided by 2. So the base of this triangle is 3, the height is 4. So 3 inches times 4 inches is 12 squared inches. Remember, when we do inches times inches, it becomes inches squared. So 12 squared inches divided by 2, well, 12 divided by 2 is 6. So the area of this triangle is 6 squared inches. Okay, next shape we're going to look at is a circle. The area of a circle can be found by multiplying pi by the radius squared. So the equation for area of a circle is area equals pi times r squared. So remember, pi is a number that is somewhat equivalent to 3.14. And our radius is the distance from the center of a circle out to the edge. It's important to remember that the order of operations state that you have to square the number, so we have to square the radius before multiplying by pi. And squaring a number, if you recall, is just multiplying it by itself. So let's see an example. So find the area of the following circle. So take a minute, pause the video, and see if you can find the area. Okay, so remember, area of a circle is pi times r squared. In this case, our radius, so the distance from the center out to the edge, is 5. So we get pi times 5 centimeters squared. So we square the number first, so we're going to square 5. Remember, squaring a number is just multiplying it by itself. So 5 times 5 is 25. So the area is pi times 25 centimeters squared. And then in your calculator, if you have a pi button, you can use that and do pi times 25. If not, you can use 3.14 times 25, and you get 78.5 centimeters squared. So the area of this circle is 78.5 squared centimeters. So those are the three main shapes we're going to be dealing with for this lesson on area. But where we're actually taking this is we're going to put some of those shapes together. We're going to make some combinations. And that's what we call a composite shape. So to find the area of a composite shape, we divide it up into shapes that we already know how to deal with. For example, if we wanted to find the area of the following shape, we don't have an equation for the area of an L-shaped figure, but we can easily divide this shape up into two rectangles. So we have rectangle 1 that has a length of 2 and a width of 8. And we have rectangle 2 that has a width of 3. Now we have to do a bit of calculation to find the width. But if the long side is 8 and the short side on the left is 2, the side on the left would have to be 6. So the second rectangle would be 6 by 3. So to find the area of rectangle 1, we do length times width, which is 8 times 2, or 16 squared centimeters. Rectangle 2, length times width, would be 3 times 6, or 18 squared centimeters. So the total area would be the 16 squared centimeters plus 18 squared centimeters for a total of 34 squared centimeters. So instead of trying to deal with the shape as a whole, we broke it up into two rectangles so we can easily find the area of. The second example looks something like this. Another shape we have no equation to find the area of, but if I break it up into two shapes, I have a rectangle and a triangle. So my rectangle has a length and a width of 10 and 4. My triangle, the base would be the red line that I drew in, which is 4, and the height would be 2. So if I wanted to find the area of the rectangle, it would be length times width, which is 4 times 10, or 40 meters squared. The triangle, the area of triangle is base times height over 2. So my base is 4, my height is 2. So we get 8 meters squared over 2, or 4 meters squared. So the total area would be the 40 meters squared from the rectangle and the 4 meters squared from the triangle, for a total of 44 meters squared. So it's really important when you're doing these composite shapes that you break it up into shapes you know how to deal with. So some other things you might see is a semicircle attached to maybe a rectangle. We saw that in the perimeter problem, where you would have to find the area of a circle and cut it in half for a half of a circle. We could see triangles and circles, rectangles and rectangles, all kinds of different combinations. But as long as you break them up into shapes you know how to deal with, you shouldn't have any problems. So try the worksheet that's included with this lesson and see how you do.